Alright, so you are going to be able to use this on your test, which is going to be next week. So we've covered several different things, so I wanted to make you a little cheat sheet so that you will be ready. Top right hand box, you can see I just folded my paper into 4 squares or rectangles, kind of like we always do. So we're going to cover the first derivative test first. Okay, steps for the first derivative test. Remember, the first thing that you need to do is find f prime of x. And then you're going to find your critical numbers by setting the derivative equal to 0 or undefined and solving. Okay, those are going to be your critical numbers. Then you're going to do your interval test. Okay, and then from there you can identify your relative extrema. Remember that extrema refers to both mins and maxes. Okay, you have a relative minimum when f prime changes from negative to positive. And you have a relative maximum when f prime changes from positive to negative. Okay? Also remember that your min and max value is the y value, and it occurs at the x value. So we would say, the maximum height of the ball is 48 at 3 seconds. So make sure that you understand your verbiage there. Now also remember that these are to find relative extrema. Okay, that does not make them the absolute extrema. Remember to check and see if something is the absolute extrema or min or max. Okay, the absolute, you would have to do a line chart. So make sure that's always going to be on an interval. And you would do a candidates table or a candidacy chart. And so remember, on that chart, you would have x and y. Remember, you're always plugging into y, which would be the original function, okay, or your f of x. You would put your critical numbers in there. You would put your endpoints in there. And then your absolute max would be the biggest thing on that chart. Your absolute min would be the smallest thing on that chart. Okay? Alright, the other thing you need to know how to do is a second derivative test. Second derivative test. Okay, and for the second derivative test, you are going to need to find the second derivative, f double prime of x. Okay, then you are going to set f double prime of x equal to 0 or undefined. And you are going to find what are not called critical numbers, but are sort of the equivalent for that for the second derivative. Okay, then you're going to do an interval test. Now remember, on the interval test, you're checking for the signs of f double prime. Okay, and then you can use that chart to identify your inflection points. Points of inflection. Okay, now remember, your points of inflection are specifically POI is going to be when f double prime changes sign. Okay, remember that you can also use the second derivative test to determine where your graph is concave up and concave down. Just like on a first derivative test, you can tell when your function is increasing or decreasing. Okay? Alright, the next thing that we are going to talk about, go ahead and come down to your bottom 2 boxes. Okay, is we are going to make a little graph here, and we are going to describe the relationship between f prime, and f double prime. Okay. When f is increasing, okay, we know that f prime is positive. When f is decreasing, we know f prime is negative. Okay, remember that increasing and decreasing do not tell us anything about f double prime, which is concavity. But if f is concave up, then we know that f prime was positive. Okay, if f is concave down, then we know that f prime was negative. However, remember that f double prime also tells us stuff about f prime, because f double prime is the derivative of f prime. So if f double prime is positive, that means that f prime was increasing. And if f double prime is negative, that means that f prime was decreasing. So that might kind of give you a bit of like a pictorial, okay, explanation or connection between those. You could also label each of these as this would be your position, okay, which describes your velocity, which describes your acceleration. Okay, so all of those relationships would be consistent with first, second, and the original and the first and second derivative. Okay? Just some other really basic definitions, okay, that we're going to just go ahead and scribble down here at the bottom. Remember that f is increasing when f prime is greater than 0, and f is concave up when f double prime is greater than 0. Okay. Now, if f is concave up and f double prime is greater than 0, you could also say, okay, we're going to put just like a little star here, okay, that if f double prime of x is greater than 0, that does also mean that f prime of x is increasing. Okay? And so that's something that you should be able to understand, because f double prime represents the slope of f prime. So that connection should kind of make sense too. Okay, the last thing that we're going to sketch, I'm going to try to squeeze it in over here, okay, is going to be just a real quick graph of f prime. Okay, we did one of these in class today as one of our examples. Okay, but a graph of f prime, let's say your graph goes something like this. Okay, it goes up, down, touches the axis, and then comes back down. Okay, your critical numbers would be each of these x-intercepts. Remember that they count as critical numbers because that's where f prime of x is equal to 0. Okay, then from there you should be able to label each of those as a min, a max, and either. Remember that a max occurs when your graph changes from above to below, so that would be a max. A min occurs when you change from negative to positive, which would mean below to above. Okay, this third one would be a neither. And remember that it's a neither because it's from negative to negative. It stays below the x-axis. That does not count as a sign change. The other thing that you should know is how to find points of inflection. Remember, these are the x's that we place on our graph. Okay, and remember that each of those x's is a point of inflection, which means that f double prime, the slope of f prime, changes sign. Okay, and remember that the direction of that sign change does not matter. Okay? All right, go ahead and turn over to the back, and we will do a little bit of position, velocity, and acceleration. Okay? All right, on the back, top right-hand corner, we are going to talk about velocity. So remember that if position is x of t, it is also sometimes called s of t. Okay, then the derivative of that would be velocity. So velocity equals x prime of t or s prime of t. But typically you call it v of t. That would be your most common definition, but remember you would want to make sure you link it back to whatever you were given. Okay, remember that velocity tells you direction. Okay, v of t tells you whether position is increasing or decreasing. And so the reason that it's important that you're able to tell whether it's increasing or decreasing is that also tells you the direction. Okay, so put a little star. Tells you the direction. Okay, if your thing is increasing, that typically means up or to the right. If your position is decreasing, that typically means down or to the left. Okay, and it just depends on what kind of axis you're on, if you're on a horizontal or a vertical axis. Okay, velocity also would be considered at rest when v of t is 0. And remember that when v of t changes sign, that tells you when the particle changes direction. Okay? So those are some of the highlights of velocity. The other thing that we have talked about is acceleration. Okay, remember that acceleration is x double prime or s double prime of t. Okay, it also could be defined as v prime of t. Okay, but typically it is a of t. Okay, and so you would usually have to have found the velocity first, which means v prime would be fine for that. Remember that acceleration tells you if velocity is increasing or decreasing. Now remember that this is not the same as if speed is increasing or decreasing, so that is not the same thing. Okay, so the other thing that you would need to know is how to tell if speed is increasing or decreasing. So speed, which is not the same as velocity, is increasing when v of t and a of t have the same sign. So remember, if your velocity and your acceleration are both negative, that still counts as your speed increasing. Your speed would just be increasing down or to the left. The other thing that you should know is for towards or away from the origin. Okay, and for towards or away from the origin, you would need to check the position and the velocity. Remember that the position tells you which side of the origin the particle is at. And remember that v of t tells you the direction it's moving. Okay? And so at that point you would just be able to kind of put together, okay, if I'm on the left, okay, think about like that squirrel problem we did where he's running on the number line. Okay, if this is the origin and your particle's here and it's moving to the left, okay, then that means that you're going towards. Okay, if you're on this same side and you're moving to the right, that would count as away. Alright, so make sure that you write this down. Okay, your partner test is going to be on Wednesday. Partner test is going to be on Wednesday. And your CBA is going to be on Thursday. Okay, then the Friday before Thanksgiving, I'm going to cut you guys a break and we're going to make some really fun hand turkeys. Okay, so make sure you write down your cheat sheet. Don't lose it. See you on Monday.